reason that we're here today is because I want to see what you know about electromagnetic energy. So the first thing I'm going to do is ask you some questions that I want answers to. And you might need to look in your Google Doc to get the answers, but I want some answers. So I'm just going to move this around so we can get sort of everything while I'm talking. So the first question I want to know is, what is energy? Anybody?
The ability to do work.
Okay, so what does energy look like? How about someone from Mr. Crosby's class? What does energy actually look like? Okay, I'll give you a hint. I don't see much energy happening over there.
So if she doesn't see much energy happening here.
It's because you're not moving that much.
Because why? Say that again.
Something moving.
Right. So in order for energy to happen, in order for energy to be happening, I have to be able to see something moving. And if nothing's moving, I don't see energy. And I don't know that energy's happening. I can also hear energy, like you're hearing me right now. That's what kind of energy?
Sound
energy. So if you hear me, that's sound energy. But when we see things moving, there's a reason that they're moving. And your form of energy is electromagnetic energy, which means something moves due to electricity and magnetism. Electricity and magnetism. So we need to figure out what kinds of things we could move with electricity and magnetism. What do magnets do? How can magnets move anything?
Paper clips.
So what could we do with a paper clip? Because a paper clip is not a magnet. How can we get a paper clip to move with a magnet?
We could bring it close and then have the paper clip be attracted to the magnet.
Okay, you have to speak really, really loud so they can hear you. So,
No.
say that louder. Jeremy.
We put the magnet close to the paper clip and let it attract to the magnet.
Okay, so if we have a magnet close to a paper clip, we can get the paper clip to move. So that's magnetic energy. We can actually do that. But I want electromagnetic energy, which means I have to add electricity there somehow. Why would I add electricity to a magnet? What do you think it would do?
To make it stronger.
Right, it's going to make it much, much stronger. Have you ever seen those huge magnets that lift up cars? You know, like in a what do you call that place where the car, like the wrecked cars are?
Junkyard?
Yes, and they lift up the car and they move it over to another place. Raise your hand if you've seen that on TV or something, right? That's an electromagnet, because the magnet alone isn't strong enough to lift the car. But we add electricity to it, it makes that magnet really, really powerful. And guess how we cut the energy off? Right, we turn off the electricity. So an electromagnet runs on a switch. We turn it on, we have a lot of energy. We turn it off, we lose the energy. So we turn it on, we lift the car up. We turn it off, what happens to the car? It falls. The car falls. Exactly. So we turn it on.
I've got a magnet and a paper clip. Can you see that?
Yeah.
Closer.
Oh, and there it goes. Now if you could turn that magnet off, you'd be able to drop that paper clip. But since we can't turn it off, why can't we turn that magnet off?
Don't have electricity.
Right, it's not running on electricity, so we can't turn it off. This has to go down here so we can all be in there. So what your goal is to figure out places, find places where we use electricity and magnetism, and I just told you one. What was it? Where was that?
Junkyard.
The junkyard, the magnets in the junkyard. So you need to find places. Can you write this in the doc? Go all the way to the bottom, and or maybe at the very top, and write the questions. You have to find places where there's electromagnetism. So that means a switch turns the magnet on, and a switch turns the magnet off. Now I'm going to bring the camera over to here. Jeremy, you don't seem to be working. So in your Google Doc, you wrote that? What else do you think you need to know at that point? You have to teach everybody about electricity and magnetism. How are you going to do that? What could you do to teach everybody? Could we go to a junkyard? Wouldn't that be a cool field trip?
Yeah.
But we can't. So what do we have to be able to do in the building? Or
Make something.
make an electromagnet. You can make an electromagnet. It is so easy. You know what you have to do?
I do.
What?
You need wire and then something metal. And then you wrap the wire around the metal thing. And then you run it through a battery. And then the metal thing turns into a magnet.
So the battery is giving us what?
Electricity.
Right. And the coiled wire, the wire wrapped around, makes the magnet. That's what makes the magnet. So we're actually going to make, you actually have to make a magnet. So that's not the next thing you need to do. Find out how to make an electromagnet. Find out how to make an electromagnet. So for potential and kinetic energy, when will it be potential?
When it's unplugged.
And when will it be kinetic?
When it's completely around.
Okay, so in the car, right, we turn it on, we have energy, we lift the car. We turn it off, the car falls, but we still have this potential energy. All we have to do now is turn the switch back on. So that's potential and kinetic energy. Now there's one more experiment we need to come up with. What's the other experiment? Remember the third part we have to come up with? We had to do potential. Look in your doc, it should be there. Right, the transformation of energy. So what you need to find, and you're going to find it here, where you find where electromagnetics work, electromagnetic energy works. I'm going to give you an example, and then you have to find your own example. There are trains called maglev trains that run on electromagnetic energy. You turn on the switch and the train moves. You turn off the switch and the train stops. And the cool thing about these trains is they float. There are magnets on the bottom of the train and they float on top of other magnets because they have the same poles, so they're repelling. So these trains float. And when you turn it on, it moves, and when you turn it off, it comes down and stops floating. But what's really happening there is that the reason it's moving forward is gears are being moved. So it's taking magnetic energy and turning it into mechanical energy. It's moving gears to get that train to move. You need to find other examples. So other examples so that you can come up with a transformation. Mr. Crosby, you want to add something there?
I was just telling them to type in there, the junkyard example and the train example, and then the fact, you're putting there that we have to find more examples.
I wonder if we can build like a junkyard, but
No, I'd
tiny,
rather build the train.
like a tiny junkyard.
I'd so.
Wait,
I have
what was
no
that experiment that we saw that you guys
That was
wanted
the
to
thing
do?
I explained.
What
Yeah,
was
where
that?
is it?
Oh, to build an electromagnet, you mean?
Yeah, like, where is it? Tell me. Help me find it.
Building an electromagnet would be perfect
Yeah,
for showing potential and kinetic energy.
It would be so much more fun to build
There's the train.
Yeah,
Here's the train.
yo, wasn't it this project? Oh, no.
No, that's not an electromagnet.
Train.
Don't put it so close.
Train.
So we're going to be looking for experiments. Right now, why don't we decide which one is doing potential and kinetic and which one is doing transformation? So Mr. Crosby's group, do you want to do potential and kinetic?
No, I'm gonna do potential and kinetic.
You gotta do an experiment. You want to transform it?
Okay, so you're going to find something where you
Uh-huh.
can transform energy and get something to move, and they're going to create an electromagnet. So what you need to do, and we'll put it into the doc as an example, you need to set up an experiment.
Here, let's
And
do
we'll put into the doc a way to write up the experiment, because whatever you find, they need to redo. And whatever they find, you need to redo.
So in other words, when they come up with their experiment, they need to write it up, because then you guys have to do their experiment
Yes.
here. Whatever experiment you come up with, you've got to write it up and explain it so well that they can follow those directions and do that
So
experiment.
we could write like the materials and how we did it?
Exactly, that's what you're doing. So you have to write the materials, and let's keep the materials simple so we can all find them. You know, maybe things we can find at home. So the plan is that by next week, you will have answered those few questions and each come up with and written up the experiment. So when we meet again next week, we're going to switch information, and then you all have 2 experiments to perform, and then we'll meet again and see which one you want to present to everybody. Because you get to teach everybody about electromagnetic energy.
Same
Bye.
Bye.
thing.
Bye.